knowing that, when we're asked to evaluate log to the base 1/4 of 16, what is our thought process? What are we trying to figure out? How should we be thinking when we try to evaluate log to the base 1/4 of 16? 1/4 raised to what power equals 16? Okay, so we're thinking 1/4 raised to what power equals 16. And whatever power that is, that's our answer, right? Okay, all right. So this one's a little tough because it's a fraction, okay? But let's just try some numbers here a little bit, okay? Let's just try a 1, all right? What's 1/4 to the first power? 1/4, right? Because anything raised to the first power is itself, right? What would 1/4 to the second power be? 1/4 times 1/4. 1/16, right? Because 1/4 times 1/4, 1 times 1 is 1, 4 times 4 is 16. So 1/4 to the second power would be 1/16. What do you think the answer is then? If 1/4 to the second power would be 1/16. -2? Try it. Try it on your calculators. Take 1/4 and raise it to the -2 power. See if you get 16. Do you?
So if it's a fraction,
There's a chance there's probably going to be a negative involved. Yep, Zach, absolutely. If you got a fraction, probably, not necessarily, okay? Not necessarily, but if one of them's a fraction and one of them's an integer, probably going to be working with negatives in some aspect. So -2 would be our answer on that one. Okay? What do you guys think on that? Okay, makes some sense? Okay? All right, good. What else can I go over with you?
What about 14? It's just the other way.
Sure. Yep, 14 says log to the base 3 of 127. So log to the base 3 of 127. All right. So again, how should we be thinking? What thought process should we be going through our head?
3 to 1 power.
3 to what power equals 1/27, right? Okay. 3 raised to what power equals 1/27? Or what exponent does the 3 need in order for it to equal 27? Paul?
-3.
You're thinking -3? Why do you think that?
Because the negative would make it a fraction. And then
But why 3?
3 because the 3 raised to the positive 3 power is 27.
3 times 3 times 3 is 27, right?
Right.
So 3 to the positive third power, 3 to the positive third power would be 27?
If you put the negative there, then it's supposed to be.
Yep, yep, so this answer would be -3.
That makes sense.
That make some sense?
Yep.
Okay? Alright, good. Any others? Any others there, guys? So now we've done, that was number 14. So we've done 16, we've done 14. Put these down, alright?
what about, like, it says you can use your calculator, but how do you like put that in?
Sure, yep. Even if you haven't completed this whole section, guys, that 8 through 19, do you guys think you have an idea on how to complete those now?
Yeah.
The thought process, whatever you need to take, okay? Alright, then if you would turn to the next page, 504, and Zach's essentially asking the next section of problems, just say calculating logarithms, use a calculator to evaluate the logarithms, okay? So that's really as simple as it sounds, alright? 23 says the log, is 23 the one you asked about?
Yeah.
So log of 6.213, okay? Log of 6.213. Now, it says to use a calculator to evaluate these because you're not going to be able to do it mentally in your head, okay? If you were able to do it mentally in your head, again, what would my thought process be if I was trying to do this mentally in your head?
10 raised to what power equals 6.213?
Yeah, 10 raised to what power equals this number right here, okay? Well, let's see, what's 10 to the first power? 10, that's too big, right? So I know my answer has to be smaller than 1, right? What's 10 to the 0th power? Careful. 1. 10 to the 0th power is 1, that's too small. So I know my answer's got to be somewhere between 0 and 1, but I don't know what that is, right? Okay? Well, because this is a common logarithm, you can use your calculator to get your answer. All you have to do is type in log 6.213, and I'm betting money you get an answer that's between 0 and 1. Probably some decimal, I'd say, you know, I don't know, 0.67, somewhere in there. 0.79, okay, so almost 0.8, all right. And that makes sense. I mean, we thought the answer would be between 0 and 1. Okay? So, that kind of good there, Zach?
Yeah, look like, with the next section, it has like log of 2 to like 32 to the x. Like, how would you do that? Or, oh wait, just kidding, that's fine. I thought it was the same thing.
Yep, but we haven't really done any of those in that next section, so I think I need to go through some of those with you. Okay? Let's see how my time is here a second. 6 minutes. Okay. Some of the problems we have not done are from section, the next part says using inverse properties. Okay? So, you guys are doing the odd ones, I'll do some even ones here, okay? Alright, so 28 says 7 raised to the log to the base 7 of x. Alright? Okay. This is one we have not really discussed yet. Okay. I'm going to have to show you what happens when you plug an inverse function into its original function to show you what happens here. Okay? If you, I don't know where I want to start with this. I want to go all the way back.